Okay, today I'm going to talk about 2.5 implicit differentiation. This is actually the second video dealing with 2.5. We're going to start off here. I'm giving you this equation, x squared minus y squared is equal to 36, and we want to find d squared y over dx squared. That, of course, is the double derivative, and we want to do that in terms of x and y. Okay, so if we need if we need to get the double derivative, of course, we got to start off by finding the derivative, finding dy over dx. We're going to do that implicitly here. I want to remind you that when we take the derivative implicitly, as we take the derivative of x is the independent variable, so it behaves like it normally does, let's say, where y is a dependent variable, so we have to kind of see that as its own little function of x. So as we take the derivative of that, we do have to do chain rule, okay? So the derivative of x squared is 2x minus the derivative of y squared. We're going to call that 2y, y prime. And of course, the derivative of 36 is 0. Okay, so let's solve for y prime. At this point, however much work you want to show, I'm just going to go ahead and, we're going to subtract this 2x over here, and then we're going to divide by negative 2y. So simplified, this is going to be y prime is equal to x over y. And we do want to simplify these because we are going to work with it. And so, one of the things that I want you to sort of start getting in a habit is that when you're just asked to find like a derivative or something like that, if there's not a compelling reason to simplify, just leave it. Here there is a compelling reason, and that is we have to take this thing and we have to go ahead and take the derivative again. So let's go ahead and do that, and I'm going to take that down here. So the derivative of y prime, we'll call it y double prime, which is the d squared y over dx squared. We're going to use quotient rule here. So we're going to square the denominator. We're going to take the derivative of the top. X still is the independent variable, so it's going to be 1. And then, so that'll be 1, copy down the y, minus, and now we switch it. We copy down the x. The derivative of y, being a dependent variable, will be 1 y prime. Okay, now that is the double derivative. However, it says in terms of x and y. This right now is in terms of x, y, and y prime. This is where this gets a little peculiar, but realize that we actually have y prime in terms of x and y. So we're going to take this and plug it in for y prime. Okay, so what we're going to end up getting here is y double prime is equal to y minus x, and then y prime, which is x over y, and that's over y squared. And, as I've been talking about, if that's all you're asked for, you're not asked to simplify, I would just leave it like that and be done with it. Now, because at some point we are going to be simplifying these things, also, another thing is if these come up in multiple choice, typically they'll simplify the answer. Delta math makes you simplify. I do want to take this a step further. There's actually quite a lot we can do to this to make it simpler. So the first thing I would do if I'm simplifying this is I want to clear out this fraction within a fraction, what is called a complex fraction. So what I'm going to do is I'm going to multiply top and bottom by y. Okay. Now, when I multiply the top by y, I've got to make sure I distribute that. So y double prime is equal to, so that's going to give me y squared, minus, these y's are going to cancel here, and that's going to be x squared over y to the third. Once again, that might be perfectly fine for a simplified answer. The thing is that, and this is also true on CalChat, all of a sudden you look in CalChat, you feel very good about this answer, and then you look and they have y double prime equals negative 36 over y to the third. And so this type of thing is something you'll sometimes see with these double derivatives. So let me just explain what they're doing here. What they're doing to get this negative 36 is they're looking up here and going, you know what? X squared minus y squared is equal to 36. We have y squared minus x squared. Now what I can do here is I can flip this by negating both sides. So if I multiply the left by negative 1 and the right by negative 1, what I'm going to get is a positive y squared and then a negative x squared. So that'll be minus x squared, and that's actually equal to negative 36. So what they're doing here is replacing the y squared minus the x squared with negative 36. And so if I'm looking at a multiple choice, or if I look in Cal Chat, I might actually see this as the answer. So, you know, whether you get there or not, what I want you to sort of be able to do is, let's say you have this, and you see this as the answer in the multiple choice. Don't panic. You're still right here, but can you manipulate this so it is equal? Okay. So that is a double derivative. It's something you're going to see from time to time. And pretty much without fail, when they ask for the double derivative, it's always going to be in terms of x and y. So the big thing with the double derivative is that we don't leave the y prime in it. That typically is going to cost you points. You want to make sure you plug the y prime in for the y prime here, so it's in terms of x and y. So that's a double derivative. I'm going to go ahead and do a few other examples today that are a little bit more difficult today. Okay, so now we're going to write a tangent line. We have the equation 3e to the xy minus x equals 0. So something a little different than what I did in the first video. And we're going to find the equation of the tangent line at 3, 0. Now, here you can see we're giving you the x and y, so all we need is the slope. If they do just give you the x, remember we're going to plug that in here to solve for y, just like we would with an explicit equation. Okay, so to get the slope, we are going to take the derivative of this, of course. And when we take the derivative of this, we're going to use implicit differentiation. Okay, so the 3 out front, we can use the old constant multiple rule, keep that out front. Okay, and then so the derivative of e to the blob is e to the blob. And then I got to take the derivative of the blob. Now, when I take the derivative of xy, I've got to use product rule. This must be in parentheses here because it's this whole function times this whole, this whole thing times this whole thing. So this has to be in parentheses here. So the derivative of x will be 1, copy down the y, plus, now we're going to copy down the x, the derivative of y is y prime. Okay, minus 1 equals 0. Now we're going to want to solve for y prime. Now let me just make this point. They're not actually asking for dy over dx here. So you could, with a question like this, you could just plug in 3, 0, and then solve for y prime. The reason why I'm not going to do that is because I think it's a good habit to get into solving for y prime. And the reason why is anytime these problems show up on the AP test, like part A is find y prime, and then they'll ask various questions like write a tangent line or do different things with them. So I'm just going to go ahead and do that because that's a skill that's good to develop. But just to be clear, you know, from this question, you could circumvent that whole process. Okay, so now this is going to be 3e to the xy, y plus xy prime. And I'm not going to go distributing or anything here. I'm going to add this 1 to the other side. And then instead of distributing this, because ultimately I just want to get at that y prime, I'm going to divide both sides by the 3e to the xy. Okay, so then this is going to cancel, and I'm left with y plus xy prime equals 1 over 3e to the xy. Okay, so now I'm going to subtract the y. Let's do that with this. Subtracting the y here. And then I'm going to divide both sides by x. Now here's the thing, and I don't want to leave it like this because that's sort of awful looking. So what we're going to end up getting here is we're going to get y prime, right, because the x's cancel. And then what is going to happen here is as I divide by x, x is just going to end up in the denominator of both those terms. So that's going to look like this. So just put an x there. Okay, minus, and then y over x. Okay, so that is a perfectly good form of the derivative. So now I'm going to get the slope by plugging in that point. So 3, 0. So 1 over 3. X is 3. And then let me point out, it doesn't matter what x is here. E to the 0, let's leave that e to the 0. And then minus 0 over 3. 0 over 3 is just 0. And e to the 0 is 1, so this all amounts to just 1/9. All right, so now I'm ready to go. So my equation of my line will be y minus 0. Obviously, we don't need to write the minus 0, but you know, it's not a big deal. Slope is 1/9, and then x minus 3, and there you go. And I think this marker is on its last legs. And there's our equation of a tangent line. Okay, so let's keep on moving. Okay, example 3, once again we'll do an equation of a tangent line. This time we have the equation x cosine y equals 1 and the point 2 comma pi over 3. And you are getting the x and y, so we don't have to worry. But if they didn't give you the y, once again, we would plug in the x for 2, and you can see that actually unit circle-wise, you'll get pi over 3 pretty easily. Actually, there's multiples, so it's good that we're given that point. Okay, so all we need is the slope. So what we're going to do here is we are going to take the derivative. I got to use a different color here because my other one is sort of done. So we got to use product rule. So the derivative of x is going to be 1, copy down the cosine y, plus, now let's copy down the x. The derivative of cosine blob will be negative sine blob, and then take the derivative of blob, which is y prime. Derivative of 1 is 0, okay? So we want to solve for this y prime, so everything else I'm going to push to the other side. So first of all, this is going to give me negative x sine y prime, okay? And then this, we're going to subtract the other side, so this will be minus cosine y. Divide both sides by negative x sine y. And we're left with the y prime here is equal to negative over negative is a positive. Cosine y over x sine y. And that is my derivative. Now it's time to actually find the slope. So y prime, plug in this point in, 2 comma pi over 3. Cosine of y, so cosine of pi over 3, think unit circle, that's going to be 1/2. If you need to write this stuff out and do the unit circle, go for it. It really is not something I'll be checking for. It's just important we can get those values relatively easy. Sine of pi over 3 is going to be radical 3 over 2. Okay, so the 2's are going to cancel here, right? And then realize that this, I can get, you know, fractions and fractions are bad, so I can multiply top and bottom by 2, which would cancel up here, and what I'm left with is 1 over 2 radical 3, and that's my slope. Now, in past classes, when we see that radical in the denominator, you're sort of trained to always rationalize, multiply top and bottom by radical 3. In this context, it's absolutely not important at all. Having a radical in the denominator in this type of problem is fine. You'll even see it in calc books. They'll just leave it. So we're ready to go. So this is y minus pi over 3 is equal to 1 over 2 radical 3, and then x minus 2, and that is our tangent line. Okay, I got one more example for you that's a little bit different, and then that's going to be it for us on this video. Okay, final example here, a little bit different. So we're given the equation for a circle, and we want to know when the slope is 3/4. So of course, slope, we're talking derivative, so let's take the derivative of that thing implicitly. So 2x plus 2y, y prime equals 0. Let's solve for y prime here. So y prime is equal to negative 2x over 2y, so that's negative x over y. I'm kind of skipping some steps here. You know, if you need to go through that process, do it on your own. You know, I think these at this point are definitely something you can do. So here is my derivative, and now I know that that has to equal 3/4. By the way, this is also similar to the problem where they ask, does it have horizontal lines? Realize if they ask for a horizontal line, or where the tangent lines are horizontal, that would be 0 instead of 3/4, which means the numerator would have to be 0. And also sometimes they'll ask when the line is vertical, which means it won't exist, which means the denominator is 0. So just different takes on this. This is just the slope is 3/4. Now I will tell you, I've seen a common mistake here where people go, oh, the x is negative 3 and the y is 4. No. They have to be in that proportion, but they're not equal to that. Understand that this is just a situation where we have 2 unknowns and 1 equation. So we need a second equation. And the one thing you want to remember is, in this context, when we're ever looking for the second equation, always go back to that original for that second equation. Okay, so first of all, I'm going to solve for x here. So x is equal to negative 3/4 y. Okay, and then what we're going to do is we're going to take this and plug it into this equation. So x is negative 3/4 y, okay, plus y squared is equal to 25. So, wait a second. Oh, yeah, this is squared, right? X squared. Okay, so this is going to end up giving me, the negative squared will be positive, so this is going to be 9/16 y squared. Now, I'm going to have to ultimately combine these things. So the coefficient of 1 here, because I want a common denominator, I'm just going to call 16/16. All right? So now we're going to add those coefficients, like terms. So that's going to give me 25/16 y squared is equal to 25. And now I want to solve this thing. Instead of dividing by this fraction, which is going to give us a complex fraction, it's better to multiply by the reciprocal of that fraction, which is ultimately going to do the same thing. Okay, so cancels, 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 cancels. We're left with 1y squared, which is what we're looking for. And over here, this will cancel, this will cancel, this gives us 16. Okay, so of course, when we take the square root, we got to remember plus or minus. Y could be negative 4. It could also be positive 4. Okay, so those are our y values. Now we need our x values. So here's the thing, when I do my x values, we want to use the easiest equation we can, which is just going to be this equation. And by the way, if we use this, we will get extraneous. You would end up having the negatives and the positive. So it's definitely better to use this equation. Negative 4. Let's plug negative 4 into this. So x of negative 4 is equal to negative 3/4 times negative 4. So that will cancel. So that gives us x of negative 4 is equal to positive 3. So our first point is negative 4 comma 3. Oh, shoot, I have that backwards. X is 3, so 3 negative 4, that's my first point. Part of this notation, if you don't like that, this is some notation. So this is x, and I mean this is my y. Okay, so I kind of just flipped it around on you. Okay, so now let's do the 4. So let's plug the 4 in. This time I'll drop that notation because I think in the end it confused me more than anything else. So this is going to be negative 3, 4, and this time if I have positive 4 and plug that in, I'm going to end up with negative 3. So my second point is negative 3 and positive 4, and there you go. Now just to show what this looks like graphically, x squared plus y squared is something that we should have some idea of what this looks like. That is a circle centered at 0, okay, at 0, 0 at the origin, with a radius of 5. Okay, so what we're seeing here is that 3, negative 4, which is right in here somewhere, and in the fourth quadrant anyways, and then negative 3, 4, which is right in here, and we can see that's positive. I will tell you that if you took these points and plugged it back here, you would also get these points, but you would see, of course, that that's extraneous because that would give us a negative 3/4 slope. So that is it for 2.5.